Let's do an extra example about determining the enthalpy of a reaction using bond enthalpies. So let's take the reaction between nitrogen and hydrogen to form ammonia. Well, we know that nitrogen is a diatomic molecule, so N2, and that is a gas at room temperature. We are going to react it with hydrogen, which we know is another diatomic molecule, H2, which is also a gas at room temperature. That will form ammonia, NH3, and during this reaction that's also going to be a gas. Now I want to get this equation to be balanced, so I see that I can put a 2 in front of the NH3 to get 2 nitrogens on each side. But I see that also changed my number of hydrogens. I now have 2 times 3 hydrogens, which is 6. So I'm going to need 6 hydrogen on my reactant side. I will put a 3 as a coefficient in front of the hydrogen. Now I have 3 moles of hydrogen. 3 times 2 is also 6. So I have a balanced equation now. Well, one helpful thing to do with this is always to take a look at what bonds are actually formed here. So using some Lewis structures. I know that nitrogen has 5 valence electrons. And since I have 2 nitrogens, I'm going to have a total of 10 electrons in my Lewis structure for nitrogen. So I have a nitrogen and a nitrogen. Well, if I was to do it as a single bond, I would have too many electrons overall to meet the octet rule for each, because I have 8, 10, 12, 14. I can only have 10 electrons in this molecule. So, get rid of those. And I know a double bond's not going to do it. A triple bond will, though. So now I have 8 around each of the nitrogen, and I have 2, 4, 6, 8, 10 electrons overall. So I've got my Lewis structure of nitrogen. Hydrogen can only hold 2 electrons because it's such a small molecule, or small atom, so it's just a single bond between the two. And I have 3 of those HH bonds. Finally, NH3, nitrogen again has 5. 1, 2, 3, 4, 5. And I can put the hydrogens around. So share hydrogen's 1 electron with this 1 electron from nitrogen. Share that electron with hydrogen's 1 electron with that atom. And again, share. And we've got NH3. And I'm going to have 2 of those molecules. Well, now I need to look at my data packet. My data packet has all of the different bond enthalpy values. So when I look at that bond enthalpy value, I see the following information. I see that an N triple bond N is, 945 kilojoules per mole. I also see that a hydrogen-hydrogen single bond is 436 kilojoules per mole. And finally, nitrogen bonded singly to a hydrogen contains 391 kilojoules per mole of energy. So now I can take all of that information and put it into how many bonds I have and how many moles of those I have. And I know that my delta H overall is going to be equal to the sum of the bonds that are broken minus the sum of the bonds that are created. So I see here that I am breaking a nitrogen-nitrogen triple bond, so 945 kilojoules per mole. Ooh. I'm also breaking 3 hydrogen-hydrogen bonds, which is 436 kilojoules per mole. So these are my bonds broken here. And I'm going to subtract from those the bonds that are created. Oop, and I have lost all control of my Mobi. Let's try this again. Okay, it's not going to work that way. So what we are going to do is use a little mouse pad, and it's going to potentially look very funny here, but we're going to do it anyways. My bonds created, I'm going to have 2 times, I have 1, 2, 3 nitrogen-hydrogen bonds. So 2 times 3 times the actual value, the value in kilojoules, which is 391 kilojoules per mole. So that's 6 times 391, which is 2,346 kilojoules per mole. When I multiply 3 by 436 and add 945 to that, that is 2,253. Let's try the board one more time. Okay, appears to be working at least slightly now. So I'm going to have from my bonds broken 2,253, and I'm going to subtract from that my bonds that are created, because my bonds that are created are going to release energy, which is why I'm doing a negative, because we know exothermic releasing energy is negative, 2,346, and I get a total value of a negative 93 kilojoules per mole. So that means in my reaction, after I've broken all of the nitrogen-nitrogen triple bonds and broken the 3 moles of hydrogen-hydrogen single bonds and formed the 6 nitrogen-hydrogen bonds, I have an overall releasing of energy. I am releasing 93 kilojoules per mole for this entire reaction.